Radical injury, it's a very high yield topic, it's a very small topic. Let's study it very fast. So what is free radical? Free radical, it means it's free and it's radically dangerous. It means it has a free electron. It is following a rule of octet. So on the outer shell of the atom, it must have 8 electrons so that it's stable. If it's stable, it's a less energy bound electron, it's less energetic. If it's not stable, it will create havoc on your cells. So atoms or molecule with unpaired electron in outer orbit is following the rule of octet. The free electron, free radical, it's very free. It's gonna mess up a lot of physiological things in your body. Example of physiological and pathological free radical. So we make physiological free radicals. It's a part of our normal being. So physiological is that when we have oxygen, it accepts one electron, leads to formation of superoxide, it's O2. So O leads to O2, and then it gets one more electron, accepts one, becomes hydrogen peroxide, H2O2. So O leads to O2, O2 leads to H2O2, and then O2 leads to one more electron called hydroxide, so OH. Now this OH is very, very, very dangerous. It's the most damaging free radical. And if OH receives one more electron, the formation of water is done, right? So O plus 1 is O2, plus one electron leads to O2. O leads to O2, leads to H2O2, leads to OH, leads to H2O. Okay, so oxygen leads to superoxide, superoxide leads to hydrogen peroxide, hydrogen peroxide leads to hydroxide, hydroxide leads to H2O2. So physiological, in oxidative phosphorylation, it's a process done in our body. When oxygen receives 1, 2, 3 electrons, partially reduces, creates superoxides, hydrogen peroxide, hydroxide, free radical respectively. If O2 receives 4 electrons, right away it becomes water. All free radicals, hydroxide free radical is the most damaging. Okay, all out of all free radicals. So OH hydroxide is really dangerous. So we must know some way. If our body is making these free radicals physiologically, it means our body is making something that can render it completely inactive. So pathologically, so this was physiologically, right? Pathologically, ionizing radiation like creates hydroxide OH. Okay, ionizing radiation means radiation from some radioactive material like uranium. Okay, 235. Inflammation in neutrophils. So inflammation in neutrophil, O2 is converted to superoxide, O2. This oxygen is converted to superoxide, right? By NADPH oxidase, right? It's very important to remember this. NADPH oxidase, we'll know about it. So if you guys have some problem if you don't have NADPH, so you will not be able to form superoxide. That's very important. So NADPH is needed to convert O into superoxide, O2. Metal like iron and copper can result in superoxide. How? There's some disease called hemochromatosis. This is a disease in which there's accumulation of iron, and in this disease called Wilson disease, there is accumulation of copper. So these are diseases of ferrous and copper accumulation respectively. Wilson, copper; hemochromatosis, ferrous. So creation of free radical are main way the disease affect us, right? So there is something called as Fentine reaction, whatever you want to call it. So Fentine reaction by which ferrous generate OH. It's very dangerous. OH is hydroxyl group, hydroxide, and it's really super dangerous because it's really, really, really free. It needs electron. It needs to bind to something. So reaction by Fentine reaction is the reaction's dangerous reaction. It creates ferrous into OH. There's hydroxide. So very, very dangerous. Drugs like drugs like acetaminophen and carbon tetrachloride. Carbon tetrachloride means 4-chlor, 4Cl. So high doses of these drugs can cause liver necrosis by free radical generation. Okay, so if we take these drugs in a high amount, it can lead to liver necrosis with the help of free radical generation. Thyroid, T3, increase free radical formation. Of course, thyroid is metabolically really active. It's metabolically really super active hormone, especially T3. So T3 can make a lot of radical, free radicals. How do free radical harm us? Oxidation of DNA. Oxidation means just adding an O into this DNA can lead to DNA getting fast aging, cancer. Oxidation of protein. So again, this getting oxidized means it getting messed up. Peroxidation of lipids. Again, peroxidation of lipids. The lipids can be destroyed. What are the three mechanisms of removal of free radicals? So I told you, if our body is making these free radicals, our body will be removing them as well. So there's something called as vitamin K, that is antioxidant. So vitamin K is lovely antioxidant. It's like an enemy of these free radicals. Metal carriers, it means it binds these metal. So transferrin and ferritin, both of them, they bind these metal carriers. The problem is that ferrous and copper should not stay freely in the blood. They can stay in the blood, but they have to be bounded by some carrier protein. Most hormones in our body, they don't stay free. The T3 level, the free T3 is really like 1% or maybe less than 1%. I don't know. Like 99% is bounded, because T3 is highly free radical generative disease. T3 is highly free radical generative hormone. So it stays with thyroid binding this protein, right? This albumin and these protein carriers. So it stays with these proteins so that the free levels of T3 are less. Again, the free levels of iron is very bad, free level of copper are very bad. So metal carrier proteins, we need them. Enzymes, what enzyme? That's really important. So we know that superoxide is made, right? O2 is converted superoxide by NADPH. So we need to have something that destroys NADPH or that stops its formation. What happens is that something called a superoxide dismutase, it gets rid of superoxide catalase. It catalyzes, gets rid of hydrogen peroxide, H2O2, and something called as glutathione peroxide, GP. Okay, so glutathione peroxide gets rid of hydroxide, the most important one. If you have deficiency of glutathione peroxide, you will not be able to get rid of OH. If you have deficiency of catalase, you will not be able to get rid of H2O2. If you have deficiency of superoxide dismutase, you will not be able to get rid of superoxide. So each deficiency can lead to each disease. And let's talk about another question. Give example of two free radical injury. Very high yield. What is? Drugs. Acetaminophen. Every time, it's so hard name. Acetaminophen. So acetaminophen and carbon tetride. So carbon tetrachloride, dry cleaning chemical, C chlorine 4, carbon chlorine 4 converts to CCl3. So now this CCl4, it's stable, right? Because carbon has 4 what, and we have this structure right here, and it's bound, right? It's stable. Once you remove one chlorine, what happens is that it becomes a radical. And how it happens is that this carbon tetrachloride is converted to CCl3 with the help of CYP450, okay, in liver. Okay, it causes reversible damage to hepatocytes. It's good, it's reversible. And what happens is that cell swelling. You just remember that cell blabbing was one of the most reversible characteristic of reversible injury. So cell swelling happen, lot of Na pumps failing. So swelling of RER causes ribosome inactive and ribosome fallout. It causes apolipoprotein synthesis go down. What is apolipoprotein? Well, there's something called apoprotein. So apoprotein is the tagging protein that liver uses to tag things. If the liver wants to make sure that your body knows that it has been processed by the liver. How would the liver tell the body to, okay, hey, this thing I already got it, this thing I already know about it. So what happens that liver tags the protein with this, liver tags the stuff with this protein called apoprotein. Now there are a lot of apoprotein B, apoprotein 100, apoprotein 150, 120, like this, right? So apoprotein synthesis, very important for the identification of the stuff that has been through the liver. Okay, so if this synthesis goes down, liver can't repackage and send the fat away. What happened that the fat, the cholesterol, the LDL, HDL, all of these things will start to accumulate inside the liver, and the liver will start to get fatty. So this is the number one cause of fatty liver disease, when you have some injury in the apolipoprotein synthesis. And it is, thank God, a very reversible damage, because this cell swelling happens, right? Hepatocyte swelling is happening, it's reversible. Okay, another thing is figure T, reperfusion injury. Cool shit. What is reperfusion injury? Reperfusion injury, for example, this is a dead necrotic tissue. I reperfuse this, cell, and this reperfuse this cell with blood, and the blood comes out. What happens that during reperfusion of ischemic organ, that is the ischemic organ, the necrotic organ or the dead organ, the immune cell will attack the dead tissue, of course, because they are dead. In the presence of oxygen, of course, O2 is there, which will generate free radical, right? So more injury happens. Classic example is blood troponin level keep rising after reperfusion of MI. So you, for example, you just had an MI, right? You just had, and then you check the troponin C levels are through the roof, and then you check them again after like 2 hours, and then again the blood troponin levels are through the roof. So this is why the blood troponin level continue to rise after a reperfusion of heart, right? Because the immune cells, with the help of O2, they keep creating new free radicals, because these dead tissue is foreign to them now. They don't have the dead tissue doesn't have any sort of identification markers for immune cells to identify them, because they are dead tissue. So this is reperfusion injury, leads to formation of free radicals. So if you have problems in superoxide dismutase, okay, for example, if you have some problem is glutathione peroxidase. So glutathione peroxidase, you need this glutathione peroxide get rid of hydroxide. There's OH. So if you have problem here and you check your levels for superoxide and dismutase, superoxide and catalase, these levels will be normal, and you'll think everything is normal, but actually you have problem with glutathione peroxidase. So each is each, so don't try to guess, get yourself tested for these biochemical enzymes each. Okay, so that was the whole chapter about free radical injury. That's it, small chapter, very small chapter.